Supercomputing Center in Germany, has been named one of the most powerful in the world. The official results were reported yesterday during the International Supercomputing Conference in Hamburg. The massive IBM iDataplex supercomputer is 3 petaflops with more than 18,000 processors, yet it consumes 40% less energy than a comparable air-cooled machine. SuperMUC achieves these remarkable energy savings by employing an innovative cooling technology, which is inspired by the human circulatory system. Similar to how blood and oxygen are delivered throughout the body, microchannel liquid coolers transport water directly to the processors and then carry away the heat. The heat is then transported to a heat exchanger, where it can then be used to provide heat for the building. Herbert Huber from the Leibniz Supercomputing Center explains why the supercomputer is so important.
Germany is very green, so to say, so energy and power awareness is a crucial aspect in Germany. IBM came up with a direct liquid cool system, so it's a completely different cooling technology, which allows us to operate our supercomputer the whole year without any chiller, without any compressor. We can save up to €1 million per year, only because of this new cooling and system packaging technology.
SuperMUC is based on the IBM Aquasar supercomputer that was built for ETH Zurich in 2010. Both computers are significant milestones in a water-cooled computing roadmap for IBM that can be traced back to the 1960s. IBM scientist Bruno Michel explains.
In the future, we will reduce the size of the system by another factor of 10 for the next 5 years. And as time goes by, for each 5 years, we need to reduce it another factor of 10, which means then eventually a million-fold reduction of SuperMUC, so that it fits into one box, like one PC box. The entire system that's currently many thousands of cubic meters into an entire PC. That will increase the efficiency of the system by a large factor.
Now that SuperMUC is operational, it will be available for scientists across Europe to explore a wide spectrum of research. Hans-Peter Bungay from the University of Munich comments.
We want to use the SuperMUC to figure out what causes those traits. What SuperMUC will allow us is probably an order of magnitude better understanding at a level that has not been done before 20 years ago. When I heard about the size of the machine, I realized that the length scale and time scale problems would for the first time be really addressable with that machine.
SuperMUC will be officially inaugurated in July at the Leibniz Supercomputing Center in front of hundreds of guests. This is Anne-Marie Cromack reporting.